This is the second lesson in Chapter 8, which focuses on slope. So this will be primarily a review lesson, and again we'll be looking at this through the lens of geometry. So slope tells us two things about lines. It tells us the steepness of a line. If the slope is larger, then the line is steeper or getting closer to vertical. It also tells us the direction in which a line is going, depending on whether it has positive or negative slope. You need to keep in mind that when you read a graph in math, you're reading it from left to right. So over here on the right, I have this kind of goofy slope birdhouse with this weird looking infinity bird that's about to crash into the house. And this, as goofy as this is, it serves as a reminder to how slope works. That positive slope looks like this when read from left to right. Negative slope looks like this when read from left to right. Zero slope is a horizontal line, and undefined slope, sometimes known as no slope, looks like this. And we do call this undefined slope or no slope in the same manner that we talked about tangent, the trig ratio tangent in the unit circle at times being undefined. And we actually talked in class about how tangent really was just slope of the hypotenuse of our right triangle in the unit circle. So in the same manner, we don't want to use no solution or null set when we're trying to find slope. If we end up getting something that doesn't work out and we know that it's no slope, we'll just say no slope or undefined slope. Okay, so moving down, you started probably the first time you saw slope with a graph or a line that was already graphed for you, and you simply counted out the triangle, the right triangle, to determine the slope. I know this is going to spoil the fun of the problem, but we're just going to say that this actually was supposed to line up on the grid. This point's at -2, 4, and this point is at 2, -3. So the way that slope works is you want to do change in y over change in x. So we just count up 1, 2, 3, 4, 5, 6, 7. And left 1, 2, 3, 4. We usually just put the negative out front like that. On the next one, we'll do the same thing. It really doesn't matter. In fact, it doesn't matter as long as you do the math correct, which point you start with. You could start with the point on the right and work your way to the point on the left, or vice versa. So if I start with the point on the right, I'm going to rise down 2 and 1, 2, 3, 4, left 4, which is in the negative direction, so I get a positive 1/2 slope. Or I could go 1, 2, 3, 4, which was in the negative direction, and down 2, which turns out, of course, to be the same answer. I normally don't do this 2 times, but I'm just trying to illustrate that it doesn't matter which point you start with, you will get the same slope. Then with the last one, if I use the 2 points that are provided, let's say this point, and I know I'm doing a lot of work for something that's probably quite simple in this point, but just bear with me. I'm going to do change in y, so -2 minus -2. I guess it doesn't really matter which point I'm using as my starting point, but maybe I'll just say I'm using this point, over 1 minus -4. I'll get rid of some of these double negatives. And I have to remember that this represents 0 slope. And if I look at the picture, I also see that this is 0 slope, whereas undefined slope has the 0 in the denominator. So this is okay, having 0 out of 5. So go down here, this just clarifies everything that I was talking about. Here is the formal slope formula, y2 minus y1 over x2 minus x1. Here's the variable that we normally use for slope. Here's a reminder that 0 over some number n is equal to 0, whereas n over 0 is undefined or no slope. So you have to know which one's which, because you can't just stop here. You must go to this part, which is the simplified form, and the same thing here. You can't just stop and leave 5 over 0 on the test. You need to tell me that this is undefined, because otherwise I'll assume that you don't know the difference. One of the things we also do, kind of a fancy way to write this notation, is to use this little triangle symbol, which is a delta, which represents change. So change in y over change in x, or rise over run. Go to the next page. We'll just practice this a couple of times. If you're not as comfortable with slope, you might want to label your points. One of the things I also like to do, if I haven't done this well or I want to be extra cautious, is plug in the x and the y that go together right in the fraction at the start. Plug in those minus signs that come with the formula, and then carefully plug in the other y and x in the corresponding spots that they belong. So there is my simplified slope. Slope should be left as a fraction, a simplified fraction. On to the next one, maybe this one will get a little bit tricky, and we'll do it the other way. Doesn't really matter. In fact, while I do it this way, with this point, 6, negative 3 being x2, y2, you could try it the other way and you will get the same answer. And there's our slope, negative slope. And then we'll do a slightly harder problem where we're going to solve for a point. And again, we want to try and not graph these. Graphing is only going to help me check my work. I want to solve these with equations or algebraically. So my slope, which is 7/3, is going to be equal to my slope formula. And I like to have y, the variable I'm solving for, to be out front so that it doesn't have a minus sign associated with it. But it shouldn't matter. I will get the same answer either way. So 7/3 equals y minus 2 over negative 3. And then from here, like we did with similar triangles, I'm going to cross multiply and solve my proportion. 3 times the quantity y minus 2 equals negative 21. And negative answers are perfectly okay, as long as they're not distances or sides of a triangle. And I could easily go back with most of the stuff in this chapter and plug in my answers and check my work and be really confident that my answers are correct. Moving on to something else, and I think we might have touched on some of this at the start of the year. Again, review of algebra stuff, but just kind of clarifying some things about parallel and perpendicular lines, which came up in chapters 1 through 7. So we have sort of two situations. Two lines in a coordinate plane are parallel if and only if, and here are your two possibilities. A is that the slopes are equal. Or B, the slopes are undefined. Because technically they're not equal because you don't have slopes. You have no slopes. And kind of another side note, this is the case of having vertical lines. maybe we could do a quick sketch here. For example, here's my axes. And maybe I graph the line x equals 1, and I graph the line x equals 3. This is the x-axis, and this is the y-axis. Those lines don't have slope, but they still are considered, of course, parallel. So we wouldn't say that they're equal. So part B is talking about this one special case. Then on to perpendicular. Perpendicular lines, for the most part, we're going to be dealing with negative reciprocal slopes. Or another way of saying that is that the product of the slopes is -1. This doesn't seem all that important, but there are times where we might actually use this. It might come in handy. We might not be able to compare the slopes because they're variable slopes, and so they're not as tangible, but we could multiply the two slopes and see if their product is -1. So for example, if I had a slope which was 3/5, the negative reciprocal is -5/3, and their product is -1, which just helps me verify something that in that case is really obvious. Or the other situation, again, is those weird lines, those vertical lines. So two lines in a coordinate plane are perpendicular if and only if, and the other situation is one line is vertical, meaning it has no slope, and the other is horizontal. So that would mean that m, or the slope, is 0. Okay, so let's look at some practice problems, and now we're going to be focusing on the sort of the geometry side of all of this, and hopefully not going back to some of that basic algebra stuff. Here we have a triangle. We want to find the slope of AB for some reason, maybe just because that's fun. And then they also want us to find the slope of the altitude to vertex C, and also the product of these slopes. Okay, so maybe what I'll call the first part, part A, we'll find the slope of segment AB. I'll erase some of this highlighted stuff. So from A to B, or B to A. So I like to line these up, 2/9 minus 0 and 16, which is 2/-7. There's my first answer, which is the slope of one of the sides of the triangle. B, I want to find the slope of the altitude to vertex C. So I'm just going to draw a sketch of what's going on. By no means is this what the graph actually looks like. And what I remember about altitudes, and one of the reasons that they were asking me to do part A, was that whenever I sketch in the altitude, let me just make an adjustment here so that doesn't look as kind of strange. When I draw in the altitude from C, it needs to be perpendicular to the line that contains AB. So what I'm going to do is I'm going to take -2/7 and I'm going to change it into +7/2. I'm not going to put an equal sign here because these fractions are not equal. So 7/2 is the slope of the altitude to side AB through point C. And the last part is, I guess, just checking that we did this correct, and this should simplify out to be -1, which of course it does. I like doing these sketches right here, not graphing them necessarily, although I could do that on graph paper, but just to remind myself of some of this old vocab that we're going to see coming back, like altitude and median. And if the sketch isn't good enough, feel free to graph it, but you still need all of this algebraic work to justify your answers. On to the next one. And this one I'm not really going to bother to sketch. I'm just going to try and do it with the algebraic techniques. It wants me to do this two different ways. And it wants me to show that there is a right angle at C. That kind of spoils the fun. That means, unless they're lying to me, that angle C is a right angle. And I'm going to first maybe go back and use my distance formula from 8.1. Doesn't matter which order I plug in the points as long as I pair the x's together and the y's together. And I have the rest of the formula correct, like the built-in minus sign and the plus sign and the squared. And because I'm already anticipating that I'm going to have to use the Pythagorean Theorem, I'm not going to bother simplifying that, because my final answer isn't the distances. And I'm on to the last side. Okay, and the reason I didn't simplify this was, now I'm going to take these and I'm going to plug them into Pythagorean Theorem. The longest side I'm going to plug in as the C or hypotenuse. So I'm going to do AB squared equals BC squared plus AC squared and see if that actually works out. So is root 50 squared equal to root 10 squared plus root 40 squared? Or is 50 equal to 10 plus 40? So therefore, angle C is a right angle. So you almost know, well, in fact, you do know in the problem like this what the end result's going to be. And if you're not getting it to work, then you need to go back and check your work. The other way, and I think the preferred way if you have the choice, is just to find the slopes. It's way easier, and you only need to find two slopes. And what you want to see is that the slopes are negative reciprocals of one another. So the first slope I got was positive 3. And the reason I'm doing BC and AC is because they meet at point C, which is supposedly the right angle. And that's what I wanted. Those are negative reciprocals of one another, so therefore angle C is a right angle because the slopes are negative reciprocals of one another. All right, moving on to what I believe is the last page. We'll look at a parallelogram for a second, and then we'll do another test. There's two tests for collinearity. So here we have a quadrilateral A, B, C, D. The naming here is actually really important because what this tells me is it tells me where the sides are. So this is a side versus where the diagonals are. The diagonals would be the letters that are not touching or are never touching. Another way to verify that is to actually graph this, but I'm not going to do that because it's already stated the name of it, which tells me how this shape is formed. So we're going to use the slope to verify that it's a parallelogram. So I'm going to find 4 slopes. I'm just going to make up this symbol. Feel free to use it like the slope of, and then use a sub symbol for the side. And I want to make sure that I'm not finding the slope of a diagonal. So I'm using letters that are next to each other, like A and B, or B and C, or C and D, or D and A, which technically are next to each other, because if you sketch the picture, you kind of see what I'm talking about. Might be best to put the 0 after the fact so you don't get weird negatives, but it doesn't matter. Okay, that's a good sign. I have 2 sides that are parallel. Then I'll go to the other 2, and I'll be getting different values for these. And the last one, and don't you love it when one of the points is at the origin? It makes at least half of these slope number crunching stuff easier. Okay, so we've just verified something that we already knew about parallelograms, which is that there are exactly 2 pairs of parallel sides, which are the opposite sides. And then we'll verify something else that we know about parallelograms, which is that in a parallelogram, no matter how weird or ugly it is, that the diagonals are going to bisect each other. So to verify that, what we're going to show is that the midpoint, so let me just label it. Let's say this is AB, CD, so that the midpoint of AC should be the same as the midpoint of BD. This is not true for all quadrilaterals. For example, a kite, one of the midpoints for one of the diagonals might be there, and the other one might be there. So this was specific to all parallelograms. Midpoint formula, we're going to add x's and divide by 2, and we're going to add y's and divide by 2. Let me scroll up and show you where my ordered pairs are. And if this doesn't work out, then I know I've done something wrong. BD is actually really easy. 6 plus 0 divided by 2. 3 plus 0 divided by 2. Just put a weird equal sign that's sideways. So 3 comma 3 halves. And this checks out. In a lot of ways, this is sort of like a trig identity. You know what's going to happen. And all this work justifies it. It's basically a proof without reasons. The last thing that we're going to go down and look at is another test for collinearity. We had talked about yesterday in the lesson where if we had 3 points, they could form a triangle, or the triangle could collapse, and it could form, they could be all collinear, and it would just form a line segment or a line. And what we see with the case of the triangle is that PQ can't be parallel or have the same slope or be on top of QR, which again can't have the same slope or be parallel or on top of PR if this is forming a triangle. So we would get 3 different values for the slopes for the 3 different sides of the triangle. The only other situation that can happen is that the 3 points don't form a triangle in the case that they form a line or line segment, which would make all 3 slopes the same. They're not going to be parallel, but all of the line segments or lines are actually on top of one another, making them collinear. So what this says is that you can check and see if the slope of PQ is equal to the slope of QR, which is equal to the slope of PR. So we have 2 ways to test for collinearity. If it's not stated which way to use, you can decide. And unfortunately, if you test 2 of these, you still have to show the third one, even if you're certain that it's going to work for the third one, especially on the quiz or test. So here we have some data points, and we're going to determine if these are collinear. And maybe I'll call this point A, point B, and point C. So I'm going to find the slope of AB. I'm going to find the slope of BC. And I'm going to find the slope of AC. And this is maybe the only case, one of the few cases, where I'm going to write the slope as a decimal. And I'm also using a calculator to number crunch this. I've done this ahead of time. So it looks like these are going to be collinear. And I'm going to do from A to C or C to A. And I'll use 1.93 first, which means 165 needs to go beneath it. Watch out for these decimals. Don't get them out of place. Okay, so I found out that points A, B, and C, I sort of made up those names, but it doesn't really matter, that these 3 points are collinear. So read the directions. You might have choices, and then you can decide which one you find to be easier. Or if you only have to do one of them, feel free to do it both ways and see if your answers are checking out, which of course they should. So there's the end of 8.2. And in the next lesson, I'll be talking about equations of lines, which should be review, and then something new and exciting, which will be writing the equation of a circle.